Hi everyone, good day. Today I will talk about translation, and that one is a part of the geometric transformation. Besides translation, there will be reflection, rotation, enlargement. Before we start the lesson, I will introduce two terms to you, object and image. Object is a shape that you want to transform, a shape that you want to translate. And then after you translate the object, after you rotate the object, then you will get a new shape. And that one is called as an image. The definition of image is a shape after the transformation. Now we will go to the translation. Translation is a transformation in which a shape is moved vertically, horizontally, or both. And we need information, right, on how to move the object vertically, horizontally, or both. And the information will be given in the form of column factor. Look on the slide. There is an AB with a bracket, right? That one's a column factor. In that column factor, you have A and B. We need to know, right? What is the meaning of the value of A there? And what is the meaning of value B over there? Okay, we will start with the A. The value of A will help you to understand how to move the object horizontally. Horizontally means that you can move it to the right, you can move it to the left. If the value of A is positive, then you just need to move the object to the right. And if the value of A is negative, then you just need to move the object to the left, of course. And then after that, the value of B. The value of B will be used to inform you how to move the object vertically. Vertically means that you can move the object up or you can also move the object down. If it's up, mood up, right? So positive. If you're dealing with a positive number for the B, then you will move the object up. And then if the value of B is negative, then you just need to move the object down. The last one. After the translation, of course, the size and the shape of the image is the same as the object size and also the object shape. So we will go to the example. Here we have a quadrilateral. We call it as object A, and we have the shape on the Cartesian diagram. Again, on the Cartesian diagram, you need to know that we are dealing with a horizontal line called as an x-axis, and then the vertical line is called as a y-axis. After that, to know the position of the vertex, we need to understand what coordinate system is. First, we need to give a number to all lines, the horizontal and vertical. The middle one, the intersection between the x-axis and y-axis, that one is 0. And then after that, for the x-axis, if you go to the right or the right side of the 0, then you're dealing with the positive integer. So after 0, it will be 1, 2, 3, 4, 5, and 6. And on the left side of the 0 on the x-axis, it will be the negative integer, -1, -2, -3, -4, and -5. And you need to remember the gap between the units should be all the same. On this picture, the distance between unit here is 1 centimeter. Also on the y-axis, we have 0. The number above the 0, meaning positive integer. So this one will be 1, 2, 3, 4, 5, and 6. And then below the 0, you will have the negative integer, -1, -2, -3, -4, -5, -6. And the distance between the units all must be the same. On this drawing, I use 1 centimeter as a gap between units. Okay, so now we go back to the topic. We will translate this object A based on this column factor. I will write it here. I think this one can be seen, right, on the video. So this one will be, let's say, negative 5,3. If I have like a column factor negative 5 and then 3 here, then it means this one, the top number, means that you will move the object to the left 5 units, and then the bottom one, 3, meaning that you will move the object up 3 units. I hope that you do understand already the meaning of this column factor. So we will use this one first, the fancy back here. Just imagine if we want to translate an object, it means we will move the object from one place to another place, but the object is still the same. So if this one represents a bag, then after the translation, we need to have the same bag. The color should be the same, the size should be the same, the shape should be the same. Now we will predict where will the image of A be after the translation. Okay, first it says left to the move to the left 5 units, right? So we will look on the x-axis, yeah, the 4, and then you move it 5 units to the left. So 1, it will be here, right? 1, and then 2, so it will be here. 3 will be here. 4 will be here, right? 5 will be here. So I'm done on moving the object left 5 units. And then I will move it up 3 units. So it means I will move it up 3 units here. Look on the vertical one. I will move it up 1 unit. I will be based on this dot, right? So I will move it up, Z. I will move it up 1, 2, and then 3. So my prediction, the back will be over there after the translation. Now, how to draw it? How to draw the result? Using this Cartesian diagram, not using this object. Yeah? Okay. Pay attention. So now we will move the dot one by one based on this column factor. Not the dot, but the vertex of the object. First is this one. I will move it to the left, right? It says like to the left 5 unit. Okay, so this one is 1, 2, 3, 4, 5. Please look on the ruler, yeah? So it will be like this. After that, I will move it up 3 units. So I will move it up 3 units. This straight. 1, 2, 3, right? So it will be here. So the vertex on the object of A first is here, and the image of this vertex will be over there using this column factor. And then this dot, I will move this vertex to the left 5 unit. Okay, we will move it to the left. Right? Like this one become like so not accurate. Okay. Yeah, okay lah. 5 units, right? So 1, 2, 3, 4, 5. So it will be here. And then 3 units up. 3 units up. Here. Three units up. So over here. So 5, right? And then 3 units. Yes. Okay. So this is the vertex of object A, and this one is the image of that vertex. Okay, and so on. This one, we move it to the left 5 units. Five units, right? Okay. 1, 2, 3, 4, 5. And then 3 units up. So from here, 3 units up. Okay. So it will be 1, 2, 3. So this here is the image of this vertex, and then the last one is this one. 5 units to the left. 1, 2, 3, 4, 5. And then after that, go up for 3 units, right? So 1, 2, 3. Over here. So the image of this vertex, it will be over here. So I will draw it. I will connect all the image of the vertex. It will be something like this. Nah, so this one is for this, right? This one will be image of object A after translation based on the column vector -5, 3. I will give you one more example. Let's say I will move it like this one. 1 column vector will be 1, and then maybe -4. What does it mean? I will move to object to the right 1 unit, and then after that down 4 unit. Now if you do a calculation, if you want to like solve this one using a calculation, you can. But in the checkpoint, I think you still need to use the drawing. You can use the calculation just to make sure that your drawing is correct. Like this one, guys. Look on this point. What will be the coordinate of this one? This point is available above 4 on the x-axis. So 4, right? Because the coordinate system will be x, y. Where is the dot on the x-axis? Followed by what? Where is the dot on the y-axis? And after that, what? 1. Now, if you translate this dot based on this unit, it means what? it says write 1 unit. So I can say, oh, okay, for the dot 4 comma 1, the 4 will move to the right 1 unit. It become what? This one will be plus 1. It become 5. And then after that, down 4 units. If it's down, it means dealing with the what? The y-axis. What is the value of the y-axis right now? 1. Now go down for 4 unit. It means what? 1 minus 4. It will be what? Negative 3. So basically, this dot, after the translation 1, negative 4, that one will be available in 5, negative 3. Like this. 5, negative 3. Yeah? Like this one. 5 on the x-axis, negative 3 on the y-axis. The other one, what will be the coordinate of this one? X comma y. So this one will be located where on the x-axis? Above 1. So 1. And then where at the y-axis? Next to the 2. 1 comma 2. Again, 1 comma 2. I will move it right to the right 1 unit. It means it will give the impact to the value of x like this, right? So it become what? 2, yeah? So plus it by 1, it become 2. And then after that, I will move it down 4 unit. So it means the value of 2 here, I will minus it by 4. So it become negative 2. So the position of this one after the translation 1, negative 4, right? It will be 2, negative 2 here. The next one, this one, right? What is the coordinate of this one? X comma y is available above 2 on the x-axis, and where on the y-axis? 2 comma 3. So I can write it again. 2 comma 3. Move to the right 1 unit. So this one move to the right 1 unit. It means the 2 here, you add it by 1, become 3. And then after that, down 4 units. So after this, down 4 unit. It means the value of the y minus it by 4. 3 minus 4 is negative 1. So the position of that one will be 3, negative 1 here. The last one, this one, what is the coordinate of this one? Available where on the x-axis? 4, above 4. And how about the y next to the 3? The same thing. 4, 3 is the coordinate of the last vertex. You move it to the right 1 unit. It means the x, you add it by 1, it becomes 5. And then down 4 units, it means the y minus it by 4. So it becomes negative 1. So 5, negative 1. So the position will be somewhere here. And then if I connect it, it will be like this. Again, on the checkpoint, you cannot do this. This one is only for checking whether your answer is correct or not. You still need to draw this dotted line, yeah, to show how you translate each vertex. Oh, why I draw the dotted line? Okay, sorry, my mistake. It will be set. And to prove whether this answer is correct or not, I will use the back again. Move it based on 1, negative 4 as a column factor. So 1, it will be here. And then negative 4. So from 1 here, 1 unit down, 2 unit down, 3 unit down, and 4 unit down. The same, yeah? Okay, I hope that you do get it. Thank you.